This one has the flashy bit and showing a wrong bits per minute. It's a bit unfortunate. We have different versions for it. Different versions. I have a different browsers. Yeah, so we had the demo of just a synthetic version of what we are trying to do. Then we had another demo of how we actually calculate blood pressure out of these fluctuations. So this is looking at changes in the color, minor changes. Then we have the actual calculation of how we extract the blood pressure, not the blood pressure, heart rate, so the beats per minute. And we have the actual working version that is measuring your heart rate using the camera. But then with this one we had already like 10 or so versions of this. This is the one we have deployed. We have another one. It's an updated version. I don't remember what the change. The change was that the amplification will only be shown for the region of interest instead of the whole thing. But the region of interest is still needs to be manually selected. And we have a third version. So in this case, we'll have an automated ROI selection. So we'll find your face, do an ROI around it. Problem is, it's trying to say choose mark your skin, but it's not doing a really good job at it. I don't get any signal out of it. So the signal quality good meant to, yeah, we need a better ROI. Frames per second. Yeah, I can make it higher but not losing any frames in the video recording and the streaming. I'm not sure if the amplification factor only affects the display. If you're doing manual ROI, yeah, now we can see it. What's not 113 should recalculate. Are you sure it's not 127? That's like 68, 66, and the 70s. We expect around 70. Is there anything flashing? Sometimes there's something flashing on the screen. It can. There might be a calculation issue. Yeah, the automated ROI. Okay, so we have a couple changes that we would like to make. First of all, to do with the x-axis of the chart. So for the time domain and frequency domain, can we by default show the x-axis with labels, but then also have an option to turn the x-axis display annotations off, labels. Can we also have another option to show the filtered and the non-filtered waveform in both time and frequency domain in different colors? Okay, we have a question about the automated ROI. How does the system handle case where the face is partially out the frame? Okay, so we get a response. The graph axis control, a raw of this filtered signal visualization, expanded technical details, the automated ROI section. Okay, clarification on the automated ROI mode. Okay, we have raw and filtered there. It's the filter. Not sure the filter is working. Wait, let's restart. Show raw signal. Okay, the automated phase, the system will automatically find key points. Small yellow dots will show you where it's measuring from. Well, those are not great. Note that the visual green pulse effect is disabled in this mode as the signal is averaged from multiple points. Well, that's not the case. Give it this image. Can we improve the selection, the automated ROI selection? Based on the image attached, can we just select where the points where the skin is and ignore facial hair and jumper? Will it regenerate the whole code? I don't know.
So, what do you think? Pretty cool, right? We're pulling a heartbeat out of thin air.
Okay, hold on. You've built a web page that stares at me, turns my skin a sickly green, and then guesses my BPM with the confidence of a weather forecast in London. Are you trying to diagnose me or make me the Incredible Hulk?
It's not guessing, it's measuring. Your heart pumps blood, right? Every time it beats, the capillaries in your skin fill up. More blood means a tiny, tiny change in the color of your skin. We're just making that tiny change visible. We're amplifying reality.
You're amplifying the fact that I'm slowly turning into a tomato every second. That's my secret. So the code is basically a digital vampire that looks at my face instead of my neck. Less messy, I'll give you that.
Exactly. Except it's looking for the green channel. Blood absorbs green light, so when your face flushes with blood, it reflects slightly less green. We grab that signal, filter out all the noise, and amplify it.
Noise? You mean my witty commentary?
I mean, you swaying, the lights flickering, your cat walking behind you, all that stuff is a tidal wave of signal noise. The pulse is like a tiny ripple in that wave. That's what the Cascaded Band-pass filter in the code is for. It's a bouncer for light frequencies. It only lets frequencies between, say, 0.8 and 3.0 hertz into the club.
So it kicks out the super slow I'm leaning in my chair frequencies and the super fast a fly just buzzed past the webcam frequencies?
Precisely. It only cares about the range where a human heartbeat lives. Then we take that clean signal and feed it into the FFT.
The what now? The fantastic face thingy?
The Fast Fourier Transform. It's a mathematical magic trick. It takes a complex signal over time, your face wobble, as you'd call it, and breaks it down into all the simple frequencies that make it up. It's like tasting a smoothie and being able to tell someone exactly how much banana, strawberry, and spinach is in it.
So my face is a smoothie, and the FFT finds the dominant flavor, which is pulse. And that bar chart graph is the recipe.
That's a surprisingly perfect analogy. The highest bar on the frequency graph is the strongest note in your pulse signal. We just convert that note's frequency into beats per minute.
Okay, but what about the yellow dots? It looks like my face is being prepped for acupuncture by a very indecisive robot.
That's the automated ROI mode. That's MediaPipe Face Mesh. It finds 468 specific points on your face. We cherry-picked a few on the forehead and cheeks because the signal is strongest there. But then we hit a problem.
Let me guess. Beards.
Beards! The ultimate signal destroyer. It's like trying to listen for a pin drop through a woolly mammoth. The AI would happily put a dot on your beard and try to measure the pulse of your keratin.
A noble but fruitless endeavor. My beard's pulse is a steady 0. Thank you very much. So how did you make your op less beardist?
With another AI, of course. We run a skin segmentation model at the same time. On every frame, before we measure, we ask the skin model, hey, is this dot actually on skin or is it on a glorious beard? If it's not on skin, we just ignore it for that frame.
You're using an AI to check another AI's homework. I love it. It's like having a bouncer for the bouncer.
But even that wasn't enough. The biggest problem was lighting. If a cloud passes overhead, your whole face gets darker. The old code would freak out and think you were having a medical emergency.
Right, because the I'm in a shadow signal is way bigger than the my heart is beating ripple.
Exactly. So we got clever. We went ratiometric. Instead of just looking at the green value, We now calculate green divided by red plus blue.
You're dividing colors now? Are you inventing new ones? What is green divided by red? Puce?
Think of it this way. When a shadow covers you, red, green, and blue all go down by, say, 20%. But the ratio between them stays the same. The change cancels itself out. But your pulse, it mostly affects the green value. So when your heart beats, the green divided by red plus blue ratio wiggles. We isolated the pulse from the noise.
That is genuinely brilliant. You're not looking at the volume of the music, you're looking at just the baseline. So what's the end game? You sell this to doctors for telemedicine?
That's the dream. Remote health monitoring, fitness apps, maybe even lie detectors.
I was thinking more practical. I could use this to see if my date is bored by checking if their heart rate is dropping to hibernation levels, or point it out my front door to know if the pizza guy is excited to see me.
I hadn't considered the pizza delivery application, but yes, technically it would work.
See? You build the reality amplifier, I'll find the ridiculous uses for it. It's a partnership. Now, if you'll excuse me, I need to go see what my ficus tree's heart rate is. For science.
A bit of trouble fixing this. So manual ROI works. And now we're also showing the noisy signal and the filtered one. Just make sure we're getting the beats per minute correctly. Changing the light to warm LED. One of them was better. There are certain light conditions that made the recording better. Go for the default values for a sec. Don't know if the ROI is big enough. Yeah, I'm not getting strong enough signal. Can run it a bit faster. There's something not right. Okay, there's a few problems. Did you change anything to do with the calculation of the actual beats per minute of the heart rate? Because it seems like the previous version could have been better, and now I seem to be struggling getting a higher quality signal. Can you explain why that might be happening? Yeah, we had the previous version essentially working better. I think it stuffed up something with the calculation. Because we added more functionality. So this version 4 can show the raw signal before filtering. Even that, I'm not sure it's working correctly. This is all brought to you by Gemini 2.5 Pro. I might get Claude or something to double check the code. Yes, so you're absolutely right. The previous version might have seemed better, and new version is likely struggling to get high quality signal. We did not change the core BPM calculation. Yeah, the old signal raw green was doing the value from the camera. So it changed. We used to look at only green channel. Typical value of this again might be 150. Tiny pulse fluctuation might change from 150.0 to 150.2. So that's the kind of changes we're looking in the camera for. We have this simulation as well for a skin patch. So it's the kind of minor changes we're looking at. The amplification there meant to be within the region of interest. Actually meant to see the color change. It is there. So just looking at the green channel. A new signal is ratiometric, a typical ratio for G divided by red and blue might be around 0.5. Tiny pulse fluctuation. Our entire processing pipeline, filtering, FFT, visualization was implicitly tuned to handle the larger number from the old method. So everything we do is available eventually on BioniChaos.com. Anyhow, we have a bunch of versions of this thing. We're trying to, so it's like an amplification microscope. You have like a TED talk on this from whatever 10 years ago. There was a lot of hype around it. That's, by the way, incorrect. I have to stop moving to actually being able to record something. This version needs some better light as well. So if I don't move certain specific light conditions, wait, what are the settings? Yeah, we're trying to automate the region of interest selection. Yeah, I have filtering. In the new version. You can actually see the raw signal and the filtered one overlaid on top. See standard stuff. Don't get too excited about that, because I'm having trouble getting a high quality signal. I'm not sure if it's, so doing a manual ROI. Wait a sec, we wanted to actually revert a couple versions back because the automatic ROI stopped working. Revert. No. This one? Yes, yeah, the automatic, so it will detect your face. Now, it meant to only select the points where your skin is, which is obviously not doing a great job at it at the moment. But it's probably the best version we've got. This version 4. Just rename it. Rename. Yeah, version control. It's a bit of a pain. Yeah, show raw signal. We're showing the graph axis. Yeah, so this is more like the development thingy. This thing that we was struggling with. To have an automated ROI, except yeah, the chin is off and the beard. So maybe if we shave tool, you get a better signal. So all these parameters will make a difference, make an effect. We'll try to improve it a little bit, but there would be a limit. Yeah, it's like this thing that we're doing in the moment. If you sit in the right angle, like now, you can actually get your heart rate. If the light is correct, you might need more light. If you select your region of interest, we're trying to automate it. And then if you don't move, don't talk, stop talking, you can get a higher quality signal. You can see that's the heart rate there. We get a correct measurement. It's actually 63, and it's 63 on my Garmin as well. Amazing stuff. But as soon as you move or doing something funny, or the light in the room changes, then the signal quality drops to nothing. Yeah. So good luck to us all. Good luck to us all. Kind of stuff that you have to be aware of. And yes, we can improve some things. Yes, we will have some suggestions of what you can do. Do not move, this and that. Adjust controls. You can adjust the filter settings, but yeah, it will have limited. I'm not even sure the filter is working correctly. I mean, it might be, it's probably working for the calculation of the beats per minute, but it doesn't work for changing the display, which is fine. which is fine. And we have an advanced, a highly experienced developer, so we can just ask them. We actually went to a previous version of the code. What's doing the eyes? So I don't know if those. Yeah, without modifying the code, can you just answer a few simple questions? So first of all, are all the yellow dots used as ROIs? How would you, another question is like, how would you go about it if some of them are over facial hair? How would you remove those or filter those out? Would you do it manually, or can we have an automated something that will actually check the skin tone? So maybe we can select one of the yellow dots as for sure skin, for example, or it can be automatically selected as the middle of the forehead. Hopefully we don't have any hair there, or if we do, it's minor. And then based on that point, we can filter out other points that are not the same range of skin tone. How about that? How does that sound? Yeah, getting good reading, 63 BPM. My thing showing, yeah, fluctuating around the same value, so it's pretty good. Yeah, maybe they need to change the amplification factor and things like that. But the main problem is that the automated ROI should be getting the same thing, but it doesn't. Yeah, that ROI. Can we just select? We can do it manually, can we? Can we do it manually? So first of all, some of the yellow dots seem to be over facial hair. Some of them seem to be at the edges of the eyes. Are those correct? That they don't seem to be correct. Can you suggest an improvement? Essentially, what I'm trying to do is replicate the results with the manual region of interest box selection, which gives me a good BPM reading. But with the automated ROI selection, I'm getting rubbish. That's essentially what the problem is. Essentially everything we do eventually available on BioniChaos.com. Go check it out and provide your feedback.
Yo, Zik, you've been staring at that pulse tracking app for 10 minutes. Are you trying to see if you can lower your heart rate by sheer force of will?
I'm trying to understand the little yellow dots. They flicker all over my face like tiny caffeinated fireflies. Are they all ROIs? Is each one sending a tiny report back to headquarters saying, yup, he's still alive? Barely.
Not quite. That's the first and most common misconception. Think of it less like a team of reporters and more like a casting call for a very exclusive movie.
A movie called My Forehead's Inner Monologue? I'm listening.
Exactly. The code has a list of about 20 potential candidates, ideal spots on the forehead, cheeks, nose bridge where the pulse signal is usually strong. But on every single frame, it holds an audition. The yellow dots you see are the ones that pass the audition for that specific moment. They are the survivors.
Survivors of what? My terrible lighting? My existential dread?
Close. Survivors of the "Are you actually useful" skin test? Which brings me to your next question, which I can see forming in your clever comedian brain.
You know me too well. My beard. What happens if one of your star candidates, let's call him Cheekbone Charlie, decides to audition from under my glorious, signal-blocking facial hair? Does the app just trust him? He seems honest. Let him in.
Ah, the facial hair problem. That's where the real magic comes in. The app is running two AI models at once. The first one finds the face and the candidate landmarks, our hopeful actors. The second one, selfie segmentation, acts as the bouncer.
A bouncer? I love it. Does he have a little earpiece and a velvet rope?
Metaphorically, yes. The Bouncer AI creates an invisible, super detailed skin map of your face on every frame. It's like a ghostly stencil that knows, with very high confidence, this pixel is skin, this pixel is beard, this one is the frame of his glasses, and this one is the hair flopping over his forehead.
So it's a digital ghost with a PhD in dermatology.
Precisely. So before Cheekbone Charlie gets his data used, the app checks his location against the bouncer's skin map. If the map says confirmed skin, Charlie's in. His green channel data gets added to the average. If the map says, nope, that's a follicle forest, Charlie is unceremoniously thrown out of the club for that frame. He doesn't get to be a yellow dot.
So the system is automatically ghosting the hairy applicants. That is brutally efficient. I respect it. But wait, I just had a brilliant idea. I'm gonna save you all this AI mumbo jumbo.
Oh boy. Go on.
Why not just do it the old school way? Like with the paint dropper tool in MS Paint. You click on a definitive 100% skin-colored spot, say the very middle of my forehead. The computer saves that color. Then it just tells all the other little dots, okay team, you're only allowed in if you're this specific shade of Yosic beige. Filter out the beard dots because they're the wrong color. Simple. Am I a genius?
You're a very clever comedian who just reinvented a classic computer vision technique called color segmentation. And it's a great idea until it's not.
What do you mean, until it's not?
Okay, stay perfectly still. Now, just lean forward into the light a little. See that? The light hits your forehead differently. The shadow on your cheek just deepened. Your Yosic beige is now 10 different colors. Your paint dropper system would just have a panic attack and fire everyone.
My brilliant system is foiled by a 60-watt bulb.
Exactly. The AI bouncer, on the other hand, is smarter. It's been trained on millions of faces in all sorts of lighting. It doesn't just see color. It understands context. It knows that skin in shadow is still skin. It knows the texture and shape of a beard is different from skin, even if the color is similar. Your method is like a guard who only checks if your shirt is blue. The AI guard recognizes your face, checks your actual ID, and knows you're not supposed to be wearing a fuzzy mask.
So my idea is a colorblind security guard, and the app is using a psychic, all-seeing super bouncer?
That is the best summary I have ever heard. It's not a democracy where every dot gets a vote. It's a highly exclusive, AI-powered nightclub for only the most legitimate, well-lit, non-hairy patches of skin.
Incredible. I feel so validated. At least parts of my face do. The rest have been rejected. I'll have to have a word with them.
Okay, that's just based on the question we asked. Then we had some other ideas. So we have now a version of it. We'll have to test first if the manual ROI still works. Oh, this is much longer code. Yeah, it made something way more complicated. The filter works better. Well, that's how it should work. Okay, that's actually loaded something. Memory access out of bounds, what? Does it tell me to go back into that position? It would be hard. Keeps giving me errors. I like how the filter works. My light. You can see the light is actually changing stuff. Got rid of the frames per second selection. I think it's 30. It feels like 30. The green jumping between two. Okay, what happened there? Looks like a filter artifact of some sort. It's gonna give me good recording. It should stabilize on one peak there. 60 BPM. Looks good. It's 57. Yeah, now I keep moving, so it's a lot to show. And the main question is the automated thing working? Oh, it's 700 megabytes in the browser. What is it doing? It's doing something overly complicated. Overly complicated nonsense. Overly complicated nonsense. It's implemented save zone, forehead only, replaced by the broad list of facial points. 10 points on the forehead, okay. Increase skin confidence threshold, okay. Added a motion stability filter. Oof. It actually gave us two options, but the second option didn't have the code. Let's generate the code. Yeah, let's. Complete standalone HTML. Stricter skin confidence. Okay. Motion stability filter. It all sounds really good. Would it actually work? Would it actually work? It should ideally look like this. In reality, we get the very noisy signal. And we have versions of this deployed. Everything we do eventually deployed on BioniChaos.com. Go check it out. Provide your feedback. Okay, we have a version. Another version of the whole code. This will be version 5 or something. Do we actually have it? Yes. Version 5, here we go. Okay, so let's assume the manual ROI box works. These ROIs, the selection of the ROIs is not great. It's doing some automated stuff. Automated ROI can do FPS of 60. Can show the raw signal as well. What's the one on the chin? It shouldn't be there. And the quality is poor. No, just some noise. Just noise. Oh, come on. It's automatically selecting. I don't know what is it selecting. Selecting something. We don't need the chin one. We don't need the chin one. What happened to? We don't need the chin one. It's super weird. Super weird. Super weird. Can you explain what the problem might be? Maybe it's the ROI, the points that are just on the hairline potentially. Are they causing the problem, or what the problem might be? Can we like reduce the number of points or something? Okay, so I have the forehead only landmarks. Let's find it in the code. I can't believe I'm making manual changes to the code. It's ridiculous. What's all this vibe coding for? And also suggesting to change the motion threshold. No, wait, before the motion threshold. How many points are there? 6. Yeah, one of them is incorrect. One of them is incorrect. I think there's like a minimum number of points that is required. So just doing these 3. Can get rid of the chin one. Right. It's measuring blinks really well. It's not measuring blinks really well. But at least we know what a blink looks like. Yeah, I'm not able to get a good signal. I'm not able to get a good signal. Oh, come on. I'm not able to get a good signal. The calculation is wrong. So if we're doing manual ROI, yeah, that is correct. If I change the FPS, calculation is wrong. It's actually double the reading. It's not taking the FPS. It's ridiculous. Everything you add, it's breaking the thing. Yeah, for the automated ROI, I'm still getting noise. Still getting a lot of noise. Automated ROI, we should simplify the code.
Let's see the results of Operation Forehead Gang. How are we looking?
Well, the good news is we successfully quelled the rebellion started by the Beard Brigade. The bad news is it seems we have a new insurgency at the northern border. According to this, my heart rate is now 141 BPM.
141? Are you currently being chased by a bear?
Only an existential one, but look at the report card. Quality poor. It's like the yellow dots are screaming, code red, evacuate, and then whispering, but don't quote me on that, I'm not super confident. What's going on? I thought the Forehead Gang were my elite guys.
They are the elite guys, but some of them got a little too adventurous. You've diagnosed it perfectly yourself. Look at that top row of dots. They've wandered right up to the edge of the forest. Your hairline.
Ah, the Hairline Frontier. It's a treacherous place.
Exactly. It's another high contrast edge. Just like with the beard, every time you make a tiny, imperceptible head movement, that dark hairline moves back and forth under those top row dots. To them, it looks like a massive high-frequency noise.
So they're not detecting my pulse, they're detecting the seismic activity of my scalp.
Precisely. And that high-frequency noise is what's giving you the insane 141 BPM reading. The algorithm sees this loud, rhythmic noise, which is completely drowning out the real, faint pulse signal, and it gets completely fooled. The poor quality rating is the algorithm's subconscious screaming, "This signal is really strong and consistent, but it feels wrong. It feels like junk food."
It is junk food. It's a signal made of pure jitter. So what's the plan, Coach? The Forehead Gang has proven to be unreliable. Do we fire them too?
No, not at all. This is just the next stage of refining our special forces. We don't fire the whole gang. We promote an even more elite squad from within their ranks. We need to create the mid-forehead elite squad.
The mid-forehead elite squad. I like the sound of that. They have better hats, I assume.
The best hats. Our current list of approved locations for the dots is a little too generous. It includes the entire forehead. We're simply going to edit that list and be more exclusive. We'll only approve landmarks that are in the dead center of the forehead, the super safe zone, far from the hairline frontier on the north and the eyebrow canyons to the south.
So we're basically telling our dots, your new mission, should you choose to accept it, is to be as boring and centrally located as possible.
That's the mission. We want the most stable, unexciting, and reliable patch of skin we can find. And if we want to be even more ruthless, we can tighten their motion filter. We can lower the motion threshold value.
What does that do in layman's terms?
It's like telling them, I don't just want you to be still, I want you to be so motionless that a sleeping cat would look hyperactive by comparison. It makes them ridiculously sensitive to any jitter, ensuring that only the absolute most stable points get to report back.
Brilliant. Let's do it. Form the mid-forehead elite squad and then enroll them in a Zen meditation course until they achieve ultimate stillness. My real BPM is counting on it.
How good is it that the robots can do all that talking for you? Still having trouble though. Should we reduce the motion threshold? Can try it out. Yeah, there's a couple of things. First of all, just a minor change. We want the automated ROI to be selected by default instead of the manual ROI box. Now the second thing is that for the automated ROI, do we actually need a box around those dots that are you know, the yellow dots? So when we have the automated ROI selected, can we or should we have a box around it so the results are comparable to the manual ROI? Because the manual ROI does actually work and give us a good quality signal. Yeah, we do get a good signal, don't we? Yeah, generating a new version of the code. Okay, can we change the ROI selection to essentially so mark the whole forehead and then do a box within it, making sure we're not touching any hairline or eyebrows or anything like that. Can you improve it based on the image, looking at taking into account the image attached? Oh, we have trouble. Okay, can we improve the box, make it a bit higher and potentially a bit larger? Can we also show the yellow dots based on which the ROI box is being selected? And also, can you comment on if the size of the box matters for the signal quality? Will it change the signal quality or not? Also, the amplification factor of 200, is it too high? Should it be about 100 by default? What do you think? I will do an overview by Notebook LM as well, because that actually should make better sense, because they're professional podcasters talking. Still trying to do the skin, the detection. Not sure why, but we are not using that anymore. Maybe we are. Are we able to get any signal? We'll improve the... There's a signal there. There's still a high frequency component. It's actually generated the conversation as well as the code. That's pretty good. It's struggling with the face. I don't like placeholders. We'll do the chat. That's okay. We will do the chat between comedian and the data scientist. Can you regenerate the code without any placeholders? AI Studio doesn't have an enter for sending the prompt. You need the control enter instead. Yeah, it's fluctuating quite a bit. I'll try to improve it. Everything we do is eventually available on BioniChaos.com. Go check it out. Provide your feedback. Your feedback will be used as future prompts. Yeah, we're regenerating the code, trying to fix the ROI automated selection. I mean, we can do a manual one. Yeah, 63 is about right. My Garmin is showing 62. So that's correct, and you can see the signal there. It's pretty good as well. But when we select automated mode, we should get the same result. And we also do some motion, or we'll be also trying to do some motion filtering.
Misha, we have progress. The system is no longer convinced I'm a statue. We're getting a reading of 40 BPM with fair quality. We've moved from clinically dead to hibernating grizzly bear. It's an improvement.
I see it. The dynamic safe zone is working. It's staying away from your hairline and eyebrows. But the signal is still weak. And you're right, the box itself looks a little timid.
It's a postage stamp on my forehead. It needs more authority. Can we make it taller and wider? Also, I feel like we're flying blind. You told me the box was based on my surveyor landmarks, but where are they? I want to see the team that's drawing these maps.
Excellent points. We can absolutely make the box bigger and re-enable the surveyor dots so you can see the boundaries it's using for its calculations. But this brings us to a very important question you asked. Does the size of the box actually matter?
I'm on the edge of my seat. Does it?
It's a fascinating trade-off. Think of our fishing net analogy again. A larger box, i.e. a bigger net, has a huge advantage. It captures thousands more pixels. By averaging them all, you drastically reduce random noise from the camera sensor itself. It's the law of large numbers. The signal becomes much smoother and cleaner. But it also has a huge risk. The bigger the net, the higher the chance you'll accidentally scoop up a bad area, a wrinkle that moves when you frown, a patch of uneven lighting, or the edge of your hairline. That kind of motion noise is 1,000 times worse than sensor noise.
So there's a Goldilocks zone. Not too small, not too big. We need a box that's large enough to get a smooth signal, but small enough to stay in the premium grade A motionless skin real estate.
You've just summarized the entire challenge of this technology in one sentence. That's exactly right. So we'll make the box bigger by reducing the inset we apply, giving it more area for that smooth averaging. But we'll be careful not to make it too big. We will also shift it slightly higher to be even safer from the eyebrows.
Perfect. And one last thing. This amplification factor, it's at 200 by default. It feels a bit aggressive, like turning the volume up to 11. Shouldn't it be more subtle, like 100?
That's a great observation about user experience. Technically, the amplification factor is purely visual. It has zero effect on the BPM calculation. The math is done on the raw, filtered signal. The amplification is just supplied at the very end to make the pulse visible to you.
So it's just the special effects slider.
Exactly. 200 is great for a dramatic demonstration, but for regular use, a default of 100 or 150 is probably more comfortable. We'll adjust the default.
Fantastic. To recap the new mission plan. Make the safe zone box bigger and nudge it upwards. Show me the red surveyor dot so I know what it's thinking, and turn down the special effects knob to a more reasonable default.
Mission accepted. Let's regenerate the code.
Mission accepted. Misha. Okay, we're getting good enough readings. This will be available for you to play with, by the way. So getting comparable results to the manual ROI box, which is good. Can show the raw signal, show the filtering. That is correct. Yeah, once you start talking, the signal quality gets reduced. But that peak there, that's the real bits per minute. Yeah, reduce the amplification factor. Yeah, turn off the sonification. So there you go. We'll deploy on the side. Make it available for you to play with as well. There is one bug. There is one specific problem that should be an easy fix. When we change the processing FPS from 30 to a different number, the calculation becomes incorrect. Can we make sure we take into account the current processing FPS set on the slider? into the calculation of the beats per minute. That should be an easy fix. Now, another thing is that we can also make the box. Can we bring back the yellow dots and show? So we essentially want to see how the box is being selected. So we want to find all the FPS. The calculation is incorrect. Into the BPM calculation. That's beats per minute. Should be an easy fix. Yeah, I'm not showing in the automated ROI how the box is being selected. I was kind of expecting. Also, can you comment on the ROI box, how it's actually being selected? It seemed to be too narrow at the moment. Can you comment on that? I was kind of expecting it to be taller, not as flat. Thank you for subscribing to the channel. Yeah, when I go to this play demo, it just fixes the image and it shows what's the ideal signal would look like. So it's obviously fake. And it's fine now. It's also, when I ask a question, it's also generating the conversation between Misha and Yojik. So we can generate the short podcast thing. Okay, so it corrected the FPS in BPM calculation and made the dollar ROI box. This is supposedly the complete code, meant to be around 500 lines. Is the box taller? It's not really taller. It is working okay though. 63 ppm is what I get. You get a good PPG, blood oxygenation signal. Now question. I don't know what it did there with the BPM. It doesn't seem right. Did I save it?
Misha, we have a breakthrough. Look at that, 63 BPM, fair quality. We're in the ballpark of a living human. The dynamic box is a success. I'm practically ready to publish my findings in the Journal of Narcissistic Pulse Checking.
That's fantastic! The spectrum graph is showing a much clearer peak. It's not perfect, but it's 100 times better than the noise we had before. But I see a thoughtful frown on your face, which, ironically, is what we designed the system to handle. What's on your mind?
Two things. First, a serious one. I was playing with the processing FPS slider. When I move it from 30 to, say, 50, the BPM reading goes haywire. It's like the mathematicians in the back room didn't get the memo about the new speed limit. They're still doing their calculations as if it's 30 FPS.
You found a critical bug. That's an incredibly sharp observation. You're exactly right. If the FFT analysis thinks it's looking at a 30 Hz signal when it's actually 50 Hz, every frequency it calculates will be wrong. A 1 Hz peak would be misinterpreted and the whole BPM would be skewed. It's a simple fix, but absolutely vital for accuracy. We need to make sure the BPM calculator always asks the slider for the current speed limit before doing its math.
Good. Now for my second point, a matter of aesthetics and performance. This blue box, it's a bit of a letterbox, isn't it? Very wide, but not very tall. I feel like we're ignoring a lot of premium grade A skin real estate in the middle of my forehead.
An excellent point. I can comment on that. We were being overly cautious. The logic we built creates a big box around your whole forehead, then shrinks it to create the safe zone. To avoid your angry eyebrows of doom, we told it to shrink a lot from the bottom, 35%. We were so scared of the eyebrows that we ended up with a short, narrow strip.
We went too far, so we can just tell it to be a little less timid.
Exactly. We'll adjust the inset ratios. We'll tell it to shrink less from the bottom, making the box taller. This will give us a larger sample area, which, as we discussed, is fantastic for smoothing out camera noise and getting a stronger, more reliable signal. We'll just make sure it's not so tall that it gets into trouble with the eyebrows again.
Perfect. A taller, smarter box, and mathematicians who check the speed limit. Let's make it happen.
Yeah, we're getting closer. We have automated face detection. We still have didn't actually fix the FPS selection. The fixing for a different processing FPS doesn't seem to work. So we still need to fix the BPM calculation. Also, the box seemed to be still too narrow, like a letter box opening, and also it seemed to be too low, so potentially too close to the eyebrows. Can we fix that? It's nice and strong signal. 63 BPM is correct. So we don't need a garment anymore. Don't need a wearable anymore. You can just use a camera. The eyebrows doesn't seem to put it up a notch. Okay, we'll get a good reading. If we set to 60 FPS, we should have the same reading. I think removing the FPS slider. We tried fixing the BPM calculation to take into account the FPS slider, the processing FPS. It seemed to only work with the default 30 frames per second. So can you find where is it happening? Where is the error happening? Or shall we just remove that slider? What do you think? I found a problem somewhere. Right, well, because when we changed the FPS, it wasn't resetting some things before that needs to be reset. Supposedly it made the ROI box dollar higher and more confident, whatever that means. More confident. It's a box. Our box can be more or less confident.
Misha, my friend, I've got good news and bad news. The good news is the patient has a pulse, 67 BPM at 30 FPS. We're in business. The bad news is when I crank the FPS up to 60, his heart rate magically jumps to 74 BPM and the quality plummets. He's apparently having a panic attack about being processed faster.
You found it. The stubborn bug. My apologies, my last analysis was incomplete. The calculation formula was correct, but I missed a more subtle problem. It's a classic state management issue.
State management? It sounds like you're blaming the government.
Haha, not quite. Think of our signal filter like a person running on a treadmill. When you suddenly crank the speed from 3 to 6, they flail for a few seconds before finding their rhythm. The filter is doing the same thing. When you change the FPS, the filter's internal memory is full of data from the old speed. It produces a massive chaotic flail signal as it tries to adjust. The FFT sees this huge flail and thinks it's the heartbeat.
So we're measuring the filter's panic attack, not mine. What's the fix?
It's simple now that we see it. When the user changes the FPS, we need to perform a full system reset. We shout, "Everybody out of the pool." We throw out all the old signal data in the buffers, and most importantly, we give the filter a fresh start by completely recreating it. That way it starts clean at the new speed, with no memory of the old one.
A full system flush. I like it. Now, about this box. We made it taller, but you're right, it's still a bit low and narrow. It looks like it's wearing a very tight headband. It should be more like a confident crown.
I agree. Our last adjustment was too timid. We were so worried about the eyebrows that we didn't give the box enough room to breathe. We need to be bolder. We'll tell the algorithm to shrink much less from the top, pushing the box higher up the forehead. And we'll shrink a little less from the bottom too.
This will give us a taller, more confident crown that captures an even larger, more stable patch of skin.
A taller, higher crown for a more regal and accurate BPM. And a system flush for the panicky filter. This feels like the final boss battle for this project.
Let's win it. Here is the final code.
Okay, we are winning it, but there's still a few annoying little problems. Hey, can you check the two images? So the only thing we're changing is the selected processing FPS from 30 to 60, and that seemed to mess up the BPM output. Can you check the code? Let us know what's happening, what's going on. Everything we do is available on BioniChaos.com. Go check out the website, provide your feedback. Your feedback will be used as future prompts. Oh, this is wrong. I don't know why it can't solve like simple thing.
Misha, my friend, I've run the experiment. The results are in. At 30 FPS, my heart rate is a calm 70 BPM. At 60 FPS, it's a frantic 111 BPM. The only thing that changed was the slider. This machine thinks that processing me faster gives me a panic attack.
You found it, the stubborn bug. My last analysis was incomplete, and my apologies for that. This is the smoking gun. It's a classic state management problem.
It sounds serious. Are you telling me the filter has commitment issues?
Worse, it has memory issues. Think of our signal filter like a person running on a treadmill. They have a history, a memory of their last few steps. When you suddenly crank the speed from 3 to 6, they flail chaotically for a moment before they find their rhythm.
I know the feeling.
The filter is doing the exact same thing. When you change the FPS, we've been telling it, hey, use these new speed parameters, but we never told it to forget its past. Its internal memory is still full of data calculated at the old speed. That mismatch creates a massive, chaotic flail in the signal. The FFT sees this huge spike and misinterprets it as a very fast heartbeat.
So we're not measuring my pulse, we're measuring the filter's panic attack. How do we calm it down?
We don't calm it down, we give it a brain wipe. When the user changes the FPS, we have to perform a full system flush. We can't just update the old filter, we have to destroy it and create a brand new one from scratch. We also have to empty all the signal buffers. This forces a completely clean start at the new speed with no memory of the past.
A total reset. Brutal, but effective. Now about this blue box, we made it taller, but it's still wearing its pants too low. It's practically sitting on my eyebrows. It needs to be a proper crown, not a headband.
You're right. We were still being too timid. We were so afraid of eyebrow wrinkle noise that we kept the box too low. We need to be bolder and claim that prime, stable real estate in the middle of your forehead. We'll adjust the inset ratios one last time, shrinking much less from the top to push the box higher, and less from the bottom to make it even taller.
A taller, higher crown for a more regal and accurate BPM, and a full memory wipe for the panicky filter. This feels right. This is the one.
I agree. This is the definitive fix. Let's deploy the final version.
Yeah, let's deploy the final version. Anyhow, yeah, we'll check it, continue it next time. We'll check it, deploy the final version onto the site. So stay tuned. Don't forget to subscribe, like, smash that like button. Any questions, comments, complaints are welcome, as long as they are relevant to the content. Relevant to the content. And this is how it ideally should look like. Some filter artifact there, and then should get this like an ideal waveform. Quality good. I think there's also excellent. Get rid of the description at the bottom of the page. And that's not cool.